matter, this adversely affect human health in numerous ways, including by developing of chronic diseases or even contributing to premature deaths. In addition, particulate matter plays a significant role in modifying global climate. Particle mass concentration, particle number concentration, size distribution, and content varies across the time and space in relation to sources of particles in each study location and its surroundings, and to the transformation that occur in atmosphere. So that is very complex process. World Health Organization guidelines, European standards, and plans for monitoring in national and local air quality networks specify address two sizes fractions of particles, fine particles smaller than 2.5 microns, and some of fine and coarse particles that are PM, so-called PM10 particles. Clean air is considered to basic requirements for human health and well-being. World Health Organization guidelines states that annual mean particulate matter with diameter less of 2.5 microns should not exceed 5 micron per cubic meter. This is something as the guidance values since I think last summer, because they dropped it on half that was before. PM2.5 include a number of harmful pollutants, and it can penetrate deep into lungs and cardiovascular system, posing risk to human health. World Health Organization estimates that 92 of the world's population live in the places where the annual mean fine particulate matter is air exceeded the guidelines values. That is assessed when it was that old guidelines standard in 2016. In the meantime, that I think that changed because they guidance values are smaller. This is also situations in the most European cities, and therefore citizens in the Europe are at the risk to be exposed to potentially harmful levels of air pollutants. In recent years, 85 of exceedance of air pollutants registered by the Serbian Air Quality State Network were attributed to particulate matter pollution. In 2017, more than 2 from 3 of cities that belong to national and local monitoring networks register mean annual values of PM10 above annual limit. Data were collected with automatic monitoring, automatic monitors, 13 stations, and using radiometric methods collecting daily samples, that is 12 stations in 2018. In addition, in 2017, Serbian Environmental Protection Agency reported PM 2.5 level from the 8 locations in the 7 cities in the Serbia. In one location, the PM levels were above annual limit value, that is 25 microns per cubic meter. At all locations, PM levels were above annual guidelines recommended by World Health Organization. Currently, information on air quality and related hazards, including particulate matter, is mostly generic and seldom preserved as personally relevant. In order for individuals to consider air pollution and its harmful effects as something personally relevant, the information should be personalized. For example, one could offer information about indicative level of all pollutants in microenvironment along the daily route and expand how that is personally relevant by using affordable or how we call low-cost sensors, personal monitors, or by establishing dense network of monitoring units in which low-cost sensors for various air pollutants, including PM fractions, are embedded. Air quality monitoring gains novel and innovative tools ready for future challenges. The national network monitor and measure particulate matter by methods with prescribed accuracy and precision, using high-end monitors and sophisticated quality assurance and quality control system. This ensured comparability of measurements across geographic areas and meteorological and climatic conditions, but seldom provide high temporal and spatial resolution of air quality information necessary for personalized information. Lately, miniaturization and improved information of communication technologies result in availability of low-cost sensors and the use of lower-cost sensor system is increasing every day. On the market, there are low-cost sensors that cost in the range of 10 to 100 euros, and sensors kit assembled sensors that cost up to 600 euros and even more, or do-it-yourself kits from different reputable producers. The main characteristic of available sensor system were compared in number of papers. Low-cost sensors for particle matter low-cost sensors are suitable for deployment in a large number of terms and cost of the single units, but questions remain regarding of quality of data produced. There is no doubt that PM low-cost sensors may increase spatial and temporal monitoring resolution and cover a large variety of applications in cost-effective manner, but there is doubts regarding to their reliability, accuracy, and precision. So there is, I'm going to give you a few examples of successful application of low-cost PM sensors. National and local monitoring networks are limited to the few seats within a large geographic region. This limits the ability to contribute in characterizing the pollutant variability and source within complex urban topography. There are high costs of operating and monitoring the network of reference monitors, includes cost of monitors themselves, their running and maintaining, as well as rigorous quality procedure. This is a limiting factor for ability to increase spatial and temporal coverage of high quality of air pollution monitoring data. However, human exposure depends on proximity to local emissions sources such traffic intensity on the route where the people move, domestic heating and district heating sources in the area when you spend time, as well as in wider scale meteorology and microenvironment. This is one example how that distributed sensor networks are in some sample manner look. So probably most of you are familiar with this. And so a lot of sensors and using high resolution temporal and spatial data stored in the cloud, machine learning techniques, statistical modeling, and proven calibration methods result is in improved air quality monitoring and exposure assessment and mapping air pollution on the route where we are live and where we are moving. However, the human exposure depends on proximity of local emission sources, such as traffic intensity, route where we move, domestic heating, everything that I explained. In order to identify population at risk, vulnerable groups of population, to control irrelevant emissions that contribute to exposure, and for the health protection, we need information with higher temporal and spatial resolution. Many studies demonstrate that PM low-cost sensors can provide good spatial and temporal coverage of measurements. Also, data quality may be considered only as indicative, as defined in the legislation. Only few studies were done where PM low-cost sensors were used to enhance spatial temporal coverage of population by PM. One of these is studied by Geo and at other. They use portable University of Washington particles monitors, simultaneously deployed at 8 seats across the high alongside gravimetric PM monitors. They have shown that their monitor were able to identify PM hotspots or sustained higher concentrations compared with the city average PM levels. Application of low-cost PM sensors are identified for indoor and outdoor hotspot detection. The small size of low-cost PM sensors enable mobile applications such as monitoring with pedestrian, bicycles, vehicles, and even flying drones if they have batteries embedded. Measurements while moving can serve as input data to map the dynamic of PM pollution, searching for the hotspots emission, evaluating the exposure of their pollutants of individual level, or improving the temporal and spatial resolution of monitoring information. Bude and his colleagues update smartphones to become PM dosimeter and have recently presented Fine Phone, a phone-based device. This is fine dust measurement system that uses the camera and flash LED available on off-the-shelf smartphones as both a light receptor and an emitted passive clip-on dust sensors. By using camera instead of a single pixel photodiode as a light receptor in combination with image processing algorithms, they offer solutions that capture the light scatter traces from individual particles, giving additional information on the size spectrum of the observed particles. This system gives promising results while measuring coarse fraction of respirable particle matter is with the high correlation in comparison with high quality APS SMS device and can successfully capture PM10 levels under realistic conditions. Patora and Palagotas use a vision optical sensor for PM monitoring to design monitoring system that recorded and transmitted temperature, relative humidity, pressure, PM2.5, PM10. In addition, the system for GSP sensor can be used to identify hotspots of PM and PM10 along the route in the both rural and urban area. Somehow I find some very interesting examples of successful application of PM low-cost sensors in the agriculture, where application of low-cost sensors, but not for air pollution, is very wide. But for this application, it is used for off-target movement of pesticides, so-called pesticide drift, that is major source of pesticide exposure, particularly among agricultural workers. Drift can also contribute to exposure of bystanders. Drift risk is also related to spray droplet size, in particular to the percentage of fine spray droplets. Traditionally, sampling and estimation of pesticide sampling and estimation of pesticide drift have been performed using passive samplers distributed in the treated area, accompanied with methodological data. Recently published studies present a novel method of drift characterization using PM low-cost sensors monitors to estimate the spray drift potential of traditional air blast sprayer and two more modern devices that are multi-headed fan towel and erected air towel. Some authors have used several of the most popular PM low-cost sensors, Dialis DC 1100 Pro device to collect PM above and below the canopy of 5 distinct locations. Distant measurements, spray times, and meteorological observations were merged with Dialis particles number concentration and then used for calculation of PM concentration. The novel method of drift estimation with low-cost sensors were generally in agreement with result of the study performed using traditional method with passive sampling. Done during the same spray event, the Dialis monitors detected the larger difference between sprayers than the passive sampling. Measurements performed with PM collection in real time and coupled with meteorological data contributed to better understanding of how changes in wind speed and direction impact drift. Such an analysis is not possible with passive sampling. Assessment of pesticide drift with low-cost sensor could significantly reduce number of occupational pesticide drift exposures among workers on the neighborhood farms. A similar procedure may be developed for routine monitoring of pesticide drift. So that application of low-cost sensors is really very broad, and as I say, it will be here presented a few posters related to that. One of them, I don't remember now the author, but it is detecting of PM from biomass burning, and it is really few posters that present us application of low-cost PM sensors. So major advantage of low-cost particle sensors monitors are low price, portability, and comparative ease of use. There is no doubt that PM low-cost sensors may increase spatial and temporal monitoring resolution and variety of use in a cost-effective manner, but there are doubts regarding to accuracy and precision, which generally needs to be assessed as a part of each deployment. We'll have some presentations about these issues. Response to PM low-cost sensors based on light scattering method varies with aerosol size distribution, composition, and optical properties. At this time, there is no single calibration model or correction model that can enable accurate performance for all particle sources over a wide range of indoor and outdoor environments. This challenge implies the need for more research and the need to inform citizens about the advantages and limitations using such monitors. Despite the shortcomings of instrumentation, the low-cost PM sensors were successfully used for the purpose of demonstrating particle gradient within given areas, for source identification of traffic and local heating, for spatial characterization of harmful exposed from pesticide application. This is shown the potential of this device. Thank you for your attention, and have any questions?